Hey everyone, I'm sure hope you are doing great. Today's video will be about measuring voltage, current and resistance. Without further ado, let's go! First, let's talk about safety. Make sure that you never measure anything directly from the power sockets in your home. If you are using lab power supply, make sure you read the guidance and work only under supervision. If you are working on the light of Arduino or microbit, make sure it is plugged in correctly through USB to a properly ground computer or laptop. Last but not least, make sure you already watched our previous video as it will be related to today's content. Let's talk about voltage first. To measure voltage, we'll need a device that can let voltage pass through it. In this case, we use voltmeter. Voltmeter usually look like this or this. This third type is actually a multimeter. It can be used to measure voltage, current or resistance, so it will work too. The main difference between the first two is that the first one is analog while the second one is digital. Before you start using a voltmeter, make sure that their range is correct. For analog voltmeter, you can look directly on it to determine the range that it can measure, which is usually the maximum. Never try to measure any voltage that is bigger than what the voltmeter can handle, as it may break the voltmeter. The next bit is the two ports that you should use to connect to your circuits. They are usually labeled or colored with red and black, where red should be connected to the positive while black should be connected to the negative, or in another words, red to red, black to black. Similar in the multimeter, the black one should be connected to the black port, usually labeled with COM, whereas the red one should be connected to the port labeled with a capital V, usually along with other symbols as well. After that, you will need to turn the knob to the V with a straight line, not the curvy line, and select the correct range. Let's say if you are measuring up to 5 volts, select 20. But if you are measuring just up to 2 volts, select 2000 amp, where amp stands for milli. Now we have the voltmeter ready. How should we connect it to our circuits? Remember our last video. Now think of it as you wanted to connect the two circuits together. One is the circuit that you want to measure, and another one is your voltmeter. If you connect the two of them in series, they will share the voltage, so we will only measure the voltage passing through the voltmeter. That's not what we want, isn't it? However, if you remember, we can connect the voltmeter parallel to the circuits that we want to measure. This way, the circuits and the voltmeter will receive the same amount of voltage as we have learned in our previous video. Or in short, in a running circuit, all you need to do is to connect the voltmeter directly on top of the original circuits, where the red connect to the side of the positive side of the power source, while black connect to the ground side. The voltage that you measured is the voltage drop from where you connect the red all the way to where you connect the black wire, which is basically the voltage of all components enclosed. That's possible no matter how complicated the circuits is. For example, this one with two power sources that can't be solved using parallel or series can be solved by connecting voltmeter to the component that you wanted to measure. But what happens if we didn't know which side is the positive and which side is the negative? For digital, if you connect the positive and negative the other way around, you will just get the negative number with same magnitude. In short, if you get a negative number when measuring, it just means that the two sides must be swapped. As for analog, you will instead see that the needle is trying to move toward smaller than 0. That's an indication that it is a negative number, so you may need to swap the two sides. However, there is a risk in doing so, which may damage the analog voltmeter, so it is not recommended. Another function that the voltmeter provides is that it can be used to determine the difference of voltage between 2 points. While this ability is not very useful now, it can be used to determine the difference in voltage between 2 points in a more complicated circuit. In short, if the value measured is positive, the part where the red wire connected is having higher voltage than the black wire, and if it's negative, it just means it's the other way around. Well, that's all for the voltage. We'll now move on to the current. To measure current, we'll need to use ammeter, which also has analog and digital version, and look almost exactly the same with voltmeter, except it usually has an A with a straight line. This straight line indicates that it is used for direct current, which is what we have been doing so far. The connection is also similar, where red is for positive end while black is for negative end. Again, you can measure current on your multimeter. However, the connection is slightly different. It can get a bit tricky because there's a few different types. However, no matter which type it is, whether it has 3 ports or 4 ports, we are looking for the same symbol. The black wire should still be connected to COM, whereas for the red wire, you will need to look for the port that say MA, small letter M, capital letter A. It can be paired with V. It could also stand alone, or it can even pair with mu A, which is a symbol that looks like a curvy U. Or much rarer, pair with A directly. The only exception is that if there's no MA in any of the port and only has A by itself, then it is the one that you need to connect with. And last, if the multimeter only has 2 ports, then the black connected to COM, the red should connect to the other one. Then you will need to turn the knob to the section with A and a straight line. Again, it has to be a straight line, not curvy line, unless the section have both a straight and a curvy line together, then it is the one. If it has a fill range, you will need to select the correct range as well. For using with the light of Arduino, 200 M, which is 200 milli, should be enough. You shouldn't really measure anything that is above that because we only connect to MA with our wire, and anything more than that can be very dangerous. Make sure that what you are measuring is less than 200 milliampere, then we can get started now. However, before we proceed, I would like to give you the warning for the 3rd time in this video. Current of 100 milliamps to 200 milliamps is considered the most dangerous, as it is almost always fatal if it passes through your heart. The good news is, if you are dealing with Arduino, microbit, Raspberry Pi, or the like, which provide up to 5 volts, it is generally fine as the voltage is not high enough to drive the current through. If you are using a 9 volt battery or a few 1.5 volts AA or AAA batteries, that's fine as well. Just remember, never play with the power socket if we are not professional. So, how should we connect ammeter to our circuits? Should we do it like voltmeter? The short answer is no. As we learned from previous video, if you connect two circuits in parallel, the current will split between the two. So the ammeter will have a different current passing through than the component that you connected it with. But we also learned that if components are connected in series, all of them will have the same current, which is how you should connect the ammeter. So basically, if you have a complete circuit, you will need to remove the wire from the section that you would like to measure its current and replace it with ammeter. Notice that the full amount of current will pass through the ammeter, which is why it is very important to make sure that the current you measure is not higher than the maximum that your ammeter can take, as it can almost certain damage your ammeter if you did so. Now, if you are using multimeter, if the measured current shown to be less than 200 milli and that there is an appropriate range, you should turn off the power and switch the multimeter to the lower range to get a more precise answer. When measuring current, it is also similar to measuring voltage in a way that if you also get the negative number, it also means that the direction of the current flow is the other way around. It will always flow from positive to the negative side. Now, the last bit is about resistance. To measure resistance, we can use ohm meter. However, as the original ohm meter is significantly harder to use compared to voltmeter and ammeter, as you need to set it up and configure it every time, so it is not as commonly available and has largely been replaced by the use of multimeter. So, do not drag this video for too long. Let's straight away look at how to measure resistance with a multimeter. It is worth mentioning here that if your multimeter is analog instead of digital, the scale for the resistance is usually the opposite, which means the 0 is at the far right while the maximum, which is usually infinity, is at the far left. It is also in logarithmic scale instead of linear scale like the other. The port for resistance is usually paired with the voltage, so you can connect the red wire to the same port as if you are measuring voltage, and the black wire to the COM as usual. You will now need to turn the knob to the ohm section, which is the symbol as shown. As for the range, conventionally we will turn to the largest one and turn down as we need. However, there's no real restriction over here, so you can turn to any one that you like and adjust accordingly. Or if you know the rough amount, you can turn to the closest range. The key thing to remember here is that you should never measure the resistance of any component when it is live, and it may damage your multimeter. Always remember to disconnect the component that you want to measure to be safe before measuring it with a multimeter. If the range selected is too big, the multimeter will show a 0 or a very small number. So you can always change the range to a smaller number to get better precision. The resistance will never be negative, so you don't have to worry about the direction as well. So, in summary, we can use voltmeter to measure voltage, ammeter to measure current, ohm meter to measure resistance, or multimeter to measure voltage, current, and resistance. To measure voltage, we need to connect the device in parallel to the component that you need to measure. To measure current, we need to connect the device in series to the component that you want to measure. Whereas to measure resistance, it is safer to disconnect the component from the circuits before measuring it. And remember, safety is our number one priority. That's all for today. I hope you enjoyed this video, or at the very least, learn something from this video. And see you soon. Bye bye.